Hello again. In this video, after a short review of previous videos, we're going to use FFL and FFU instructions to do a simple warehousing project. Before we get started with today's video, I just wanted to inform you about all the great content I have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's have a short review. In the previous video, the array tag structure was explained. After that, some instructions of the file and miscellaneous group were explained. The file and miscellaneous, and also shift and sequencer instructions use arrays. Shift and sequencer instructions were explained in lesson numbers 9 and 10. In this video, I will use the FIFO Load and Unload instructions to do a simple project related to warehousing. So, let me explain what these instructions do, using the help window. First, I must define an array like this to store numbers. Sometimes, the memory which is used for the FFL and FFU instructions is called stack memory. Anyway, when the FFL instruction is enabled, it loads the last entered value into the next available position. The FFU instruction works inversely. As you can see, when the FFU instruction with the same stack memory is enabled, it unloads the first entered values to a destination address, and shift all data, one element inside the stack memory, which its data type is array tag. Alright, at the beginning, let me test the project. After that, I will explain how it can be done by Factory IO software. As you see, this project is related to warehousing. Here are 54 places to store some boxes. I can access each place with the stacker crane. Let's see how it can be controlled. Well, this crane has 3 digital actuators. First, let me change my controller mode to run mode. As you see, I can move the crane up and down a bit with the first digital input. Also, I can use the crane arms to move boxes to the left side with the second digital input. Similarly, the crane arms can be moved to the right side by the third digital input. In this project, I used the fourth digital input to activate this emitter to drop a box with its pallet on the crane arms. Now, let me move the crane arms to their default positions. As you see, an operator must be employed to control the crane. Note that the inserted stacker crane has 4 modes. I selected the numerical mode, which the stacker crane accepts an integer number from 1 to 54, respectively to each position on inserted racks. As you see, I can select the desired position using this potentiometer. It will be a number from 1 to 54. After that, I can press this push button to store it on the PLC memory. This can be repeated up to 5 times, to store 5 positions on the PLC memory. Here is the main part of my PLC program. I used FIFO Load and Unload instructions to store desired positions. As you see, the first desired position is 8th. So, when I press this push button, the crane will go to this position, and also it will be cleared from the PLC memory. Here, it will be replaced with position 1. Because, I used a FIFO unload instruction in my PLC program, and desired positions will be moved on my PLC stack memory. Let me press the push button. Now, I can use my real digital inputs to control the crane and put the box on the desired position. Note that, the inserted stacker crane accepts numbers 0 and 55 too. Number 0 won't change the crane position. Number 55 back the crane to its default position, where I can drop a box on its arms. So, let me press the 5th digital input. Because I used that inside my PLC program, to move number 55 to the stacker crane. Let me put another box with its pullet, on the crane arms. Now, if I press this push button, the crane will go to the first position. Now, let me put the box on the first position. If you remember, I have entered 5 positions at the beginning. Until now, the crane has gone to 2 positions. And 3 positions have remained yet. Here you can see how some positions can be stored on a stack PLC memory, and use them one after another. Now, let me show you how this system can be designed inside Factory I/O software. After that, I will explain my PLC program. First, let's insert a stacker crane from the right list. As I mentioned before, let's select the numerical mode for the inserted crane. Then, let's insert 3 racks. As you see, these 3 racks support 54 places to store boxes. Now, let me insert an emitter from the right list. Here, I determine which type of boxes can be entered. Well, to change the height of the inserted equipment, I press the V key on my keyboard, and use my mouse to change its height. Well, by default, this tag related to the inserted emitter is enabled for entering boxes. I can disable it manually, or connect that to my controller. Also, the inserted crane has 4 actuators. These will be connected to my controller. Note that, the crane has 4 sensors to detect its state. They can be used to control the crane automatically. In this video, I will use only actuator tags in my PLC program. Now, this plant is not connected to my controller. So, I must change them manually, from here. Later, I will connect these 4 actuators to my PLC outputs. And also, I will write a program to turn them on or off, using 4 real digital inputs of my hardware. This is the main actuator with this tag. It can accept an integer number from my controller. Now, let me write number 3 manually and test it. As you see, the crane is moved to position number 3. Other positions are accessible by entering a number from 1 to 54. Note that, if I enter number 0, the crane won't change its position, and I must use number 55 to go back to the default position. Alright, now, let me design a simple control box to enter, store and display 5 positions. First, let me insert a potentiometer. I will use that to select a number from 1 to 54. Note that, the inserted potentiometer voltage range is 0 to 10 volts. So, I must multiply it by 5.4 in my PLC program. Then, convert it to an integer number, to display the desired value on this digital display. Also, let me insert 5 digital displays, which will be used to show stored positions on the PLC memory. Now, let me add 2 push buttons. Note that, the red push button is normally closed. Well, there are 6 digital displays on the control box, let me define a suitable tag for each one. Now, after select my controller type, on the configuration tab, I must determine my controller IP address and its slot number. After that, I must determine suitable tags that will be used in my program. Based on these settings, these tags will be created. Let me connect each inserted equipment to its related tag. First, I connect inserted push buttons and potentiometers, as virtual PLC inputs. Then, I connect these digital outputs to 3 digital actuators of the inserted crane. The last one is connected to the emitter. I will use 4 real digital inputs in my PLC program to activate these actuators. As you see, There are 7 outputs with the integer data format. 5 of them are connected to 5 digital displays. This output sends an integer number to the stacker crane, so this output changes the crane position. The last one is used to display the selected position by the potentiometer. The next step is to define these tags in RSLogix5000 software, and use them inside the PLC program. Note that tags must be defined in the controller tags table. Let me explain my PLC program, which has been written before. At the first rung, I used a multiply instruction to convert the received voltage from the potentiometer to a number between 0 and 54, and then display the result on the related digital display. At the second rung, the first push button enables this FIFO load instruction. It transfers the selected position by the potentiometer on a PLC memory. Here, I have used this tag. Its data type is an array with 10 elements, but only the first 5 elements will be displayed by the 5 digital display. Here, I used 5 move instruction to send the stack memory values to 5 digital displays. Here, based on the program, if I press the second push button, the FIFO unload instruction transfers the first element of the selected array to the crane. It makes to change the position of the inserted crane inside the factory I/O. Next rung's logic are simple. I used 4 real digital inputs to control the crane manually and also the emitter. Finally, I used the 5th digital input to move number 55 to the crane. It makes the inserted crane goes to its default position. After transferring the program to the controller, I can go back to factory I/O software and connect that to my controller. Now I can test my project as well as the simulation which was explained before. Well, here is the end of this lesson. In the next video, we'll learn some program control instructions. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.